at lunch. All members are asked to cast their vote on our Google Stream. The winner will be announced at our next meeting. This is a reminder for students in the numeracy program that our first session will be today in room 303 at lunch. Hey Redhawks, Live Loud is happening on a special day this week to celebrate Easter. Come check us out in the library this Wednesday at lunch. We'll have some snacks and learn about the importance of Easter and Good Friday. All are welcome. Again, Live Loud this Wednesday, not Thursday this week, in the library. See you then. All right, that's all for your fantastic announcements, but I have a joke for you this morning. What do you call an electricity detective? Sherlock Holmes. All right, have a Tubular Tuesday.
Okay, so guys, let's start just with this one question you have to do for this. Okay, just one practice question. You need so for this, guys, all you're doing is completing this chart, okay? So company A, or, sorry?
All students attending the Lindsay Prep Center in the library can head down.
So this is about car rentals, okay? So it says the same type of car can be found in two different companies. So for company A, they charge $50 a day plus 25 cents per kilometer that you drive. And company B is $35 a day, so it's $50 a day less, but they charge 50 cents a kilometer. Okay. You on a field trip today? Do you have music in it? How come it says field trip? Your attendance. There's a few that are. All right, so all you're doing here, guys, is substituting when B is 0. Okay, that's pretty easy. When D is 0, if you don't drive any, it's still going to cost you $50, right? For this first one, for company A. What happens if D is 10? Right, multiply by 10, that's number, right? It's $2.50 for 10 kilometers. The distance, the D is for distance, how far you drive, right? So if it's 10 kilometers, it's going to cost you $2.50 plus the $50, right? Okay, so it's going to be $52.50. If you drive 20 kilometers, that's going to be $5, right? So you do 0.25 times 20, which is 5, plus 50, which is 55. So 20, 55, right? So every time you increase by 10 kilometers for this one, it's going up by $2.50 every time, right? Every time you increase by 10 kilometers here, it's going up by 50 cents. Does that make sense? Yeah. So 0 kilometers per year, it costs $35. Okay, 10 kilometers is going to be 35 plus 5, so it'll be $40. 45, 50, 55. Okay, and then you just graph those. Okay? So just work on that first, and then we're going to look at some graphing software. Okay. Remember, guys, there's rulers up here if you need them. Fill out the chart first. Okay. 55. Where's 50? 5 is right here. Hard to see. 40 is going to be 60, which is here. Is there. 20 is going to be 45. Here, I think. If you were to graph these guys, I know it's hard to see here, but this is so it's hard to tell, right? And it's hard to be accurate when you can't see lines either, right? It's hard to tell where the point of intersection is for the graph, right? But what happens if we were to extend this chart? If we say this is going to be 50, what's this going to be? Because every time distance increases by 10, cost increases by.
Please have a quick look at your email regarding the password change for students this morning. All teachers, please check your email for instructions regarding the password change. Thank you.
I don't have an email. Maybe it's only home living teachers that get it. Refresh here. Oh, yeah. She just sent it. Guys, all right. Yeah, I guess you're all supposed to change your password. Maybe there's been a picture or something out. Do you guys know how to change your passwords on here?
No.
I think you might be able to do Control Alt Delete.
Why do you have to change your password?
You're supposed to change, we have to change them every 30 days or something like that, but you guys, it's probably someone's been a breach or something, I don't know. Maybe someone's hacking into you. So anyway, yeah. So you guys, does anyone have their original passwords, like their street number and their birthday? Is that what you use? Yeah. You gotta change that. Well, everyone's gotta change the password. So you need one uppercase, one lowercase, minimum 8 characters. You need a number and a special character, like an @ symbol or an exclamation mark or something like that, right? Okay, so something you're gonna remember, and it can't be, what's that? So if you have your Chromebook, well, you're supposed to have your Chromebook there, if we're going to do the activity on them, so might as well take a look now and change password. I think you can do Control-Alt-Delete on your scan. No?
It might be.
Yeah, your old one should still work, but then, yeah.
Not my,
Can you do it? No, you can't do Control-Alt-Delete? Oh. Yeah, your Chromebooks might be different. So who knows how to go in and change the password? What do you have to do?
So we have to go to Chrome and then the Google account, and then you go to personal info, pull down on it, and then there's the password section, and you can.
You guys get that?
I tried to sign in with my usual password and I just got a thing because it's a password.
Oh, perfect. Okay. Yeah, so when you sign in, yeah, you could get a prompt. That's good. Yeah, if you don't update it, it might lock you.
Wait, what does the new password have to
Then you'll be
have?
able to graduate. So, okay. And one number, yeah. Uppercase, lowercase, 8 symbols. All right, so yeah, the cost is increasing on this one by $2.50 at the time, right? So this will be $62.50, and at 60, it'll be 65, right? And if we do this, 50 is going to be 60, and then 55 will be 65. Oh, 60, sorry. 60, 65. So they're actually supposed to cross over here somewhere. They're supposed to cross when X equals 30, D equals 60, and C equals 65. Okay, so 65 should be right over here somewhere. So you can see when you don't have very good graphs, right? Then it's really hard to find out where that point of intersection is, but it will be here because if we extend our chart, we know that those two spots have the same amount, right? Okay. So what does that mean? What does this point, 60, 65 mean, guys? This is where this comes, okay? So in relation to this example, what does that mean? Where the two lines cross, it means that the the y-axis over here, right? So these are starting when D was 0. C is 50, when D was 0 here, C is 35, okay? So, and then the slope of the line will determine, they have different slopes, right? The slope of this one's 0.25, the slope of this one's 0.5, right? So this one's a steeper slope. It starts lower, but it goes higher, right? This one starts higher, but it's flatter, so that is a shallower slope. But what does it mean? What's the 60 mean at this point? What's the 60? The 60 is the x value is what? What's this word right here? Distance. Okay? And what's the 65 mean? That refers to the top. So what is it at this point? Okay? This is where these two lines were supposed to meet. I know it looks like they meet here, but it's actually supposed to be here, right? What does that mean? No. What does that point mean? Oh, that's the only thing I was getting at, right? Okay. The point of intersection represents the cost, where the point where the cost is the same for either company, right? Yeah. Where the cost and the distance are the same for both companies, right? So why would that be important to know, guys? Why do we want to know that, Mark?
And then you have to go like 60 kilometers, and then it's like, which one is closer?
That's exactly it. Okay, so this tells us that it doesn't matter if we know we have to travel 60 kilometers to get to our destination, then it doesn't matter which company we go with. It's the exact same cost, right? But if we know we're going to drive further and we want to save money, right? Then it would tell, if we're going to drive further, which company, if you have to drive 100 kilometers, which company is going to be cheaper, company A or company B? What's the first one you hit when you go up here? Company A. Company A, you're going to pay this much, right? But company B is going to be up here somewhere. You're going to pay more for company B. So if you know you're going to travel more than 60 kilometers, any more than 60 kilometers, go with company A, you're going to save money. Anything less than 60 kilometers, you're going to go with company B. And then we get that pink line first, right? Okay? That's pretty good one. Well, did you forget? Okay. And when is it cheaper to rent from company B? It's cheaper if you drive less than 60 kilometers. Or traveling less than 60 kilometers. That's all I get. Yeah.
Oh, yeah, there was a problem, I think, that, oh, might be, maybe some water, but what's that? You had to shut yours down? Oh, yeah, so it might. Oh. Oh, and then it came up there, oh. Okay, so you sent an email to Matt and Mom got an email. And she said, "Just forward her." Yeah, yeah. I was thinking that. Um, Okay. on your Chromebooks are working out. You guys talk, right? Here, you look at the two equations. The equation was C equals E plus 0.25. Zoom out, it'll show you where that line is. Then we can put a second equation. So second was C equals 35 plus 5. So then you graph that for us. Okay. And then we can put the little dot inside. How will that dot will tell you what that point is. Okay. That also is a great tool for figuring out stuff like this. Okay? So I'm going to show you a couple things here. We're going to go in and figure out solving equations. Okay? So someone give me an equation of for y equals mx plus b. Okay? It's like simple numbers, but just give me a slope and a y-intercept. It doesn't matter what they are. Keep them small numbers so it's easy to see them down. 3x plus 5, perfect. Y equals 3x plus 5. Okay? Put that in and hit enter, it gives us a number. Right? So that's the graph of y equals 3x plus 5. You can zoom in if you want. Okay, if we go to the graph, we can look at this part where's the y-intercept. We zoom out, you can see the y-intercept right here. First line up, this is 5 times the y-intercept is 5, right? See that here, no y-intercept 5. So someone give me another equation with a different slope. And it doesn't matter what the numbers are. Just keep them small. Or, how about just y equals? Just keep it easy. Yeah. So y equals, or just y equals 10. Here. How about well, the slope? Because y equals 10 means it's a slope is 0, but we can do plus 10, but what should be the slope though? No, so 2x plus 10. Okay. Y equals 2x plus 10. We put that in, hit enter, there's a third option if you want, but we don't need that. So look what happens here. If we zoom in, we can see where the two lines would intersect. We know we're going to intersect from x is 5 and y is 20. Right? X is 5, we got 15, plus 5 is 20. X is 5 here, 5 times 2 is 10, 10 plus 10 is 20. Okay. X is 5, y is 20. So it's a really great source that you can use to show or figure out your answers to see if your answers are correct through our substitution and elimination. Okay, I'll show you that a little bit more after. Okay, good. All right, so they just sent
sent some different instructions here for the password reset. Here you go. So on your now reset student password. Oh. This is just for us. Just saying. For staff. School staff now reset student password. Good. Okay, we still, we able to get in, anybody? Still on here? All right. So just going back here, guys, to what you did, just solving for an unknown, okay? If we want to solve for x, that means to isolate that. How do we get rid of this 3y? This plus 3y, get rid of the 3y, or just bring it over here, right? Solve for x. X is going to equal 7 minus 3y, right? That's it. Get rid of that 3y. Solve for x. Want to solve for x here. Now it's negative, we can bring that over and that over, but if we just bring this one thing over, this would be negative 5x equals 10. What happens to this negative 15y if we bring it over? Plus 15y. What's the last thing we have to do to solve for x, get x by itself? Divide everything by negative 5, right? This is all three things by negative 5. 2 minus 2 1. Okay. Over 2x equals 16 minus 4y divided by 2. 8 minus 2y. So hopefully these are getting easier for you, okay? Hopefully you know this stuff first, because we need it later on. We need to want to solve it for y, bring that negative 8 over, so negative y equals 5x. This is going to be plus 8 now. If you don't want negative, to change all the signs. You can divide by negative 1 or multiply everything by negative 1. It's just divide by negative 1. So the negatives disappear, right? Here at 5 divided by negative 1 is negative 5, so it's minus 5x. This is going to be y, right? So here. Solve for y here. What are we going to bring over? The negative 4x. So 2y is going to be 8 plus 4x. Divide everything by 2. Half of it is 4, so 4 plus 2x. Sort of, yeah. Solve for y here. We have to bring two things over. That negative x is going to be positive, and then the 3 is going to be negative. So 5y is the positive x, so just x by itself. 3 when it comes over is minus 3. 5y equals x minus 3. Get rid of the 5 by dividing by 5. X over 5, guys. How many? There's just one x there, right? So this is the same thing as 1 over 5x. Okay. And then this just stays minus 3 over 5. Okay? All right. So the problems we're gonna deal with, guys, we know how to take an equation and make a graph out of it, right? Or make a table of values, and then we're able to graph that table of values, right? But now, and then we make a table of values for another thing, graph that, find out where they intersect. We're going to not graph. Now, we're gonna find out how to solve for two equations. Okay? So what are these things? Make it easier on ourselves, right? So if we have this equation, x minus 4y equals 8, which variable is it easier to solve for here? Is it easier to solve for x, to get x by itself, or to get y by itself? So if we got y by itself, what are we going to have to do? We're going to have to move the x over, and then we're going to have to divide it by negative 4, right? Okay? But what would we have to do to get x by itself? All we would have to do is move the negative 4y over, right? So it's always easier, if there's only one x or one y, that's always easier to solve for. Okay? Here it's easier to solve for x, right? We just have to bring this over. But it's easier to solve for x or y for this one. Why? Because there's only one y, right? If it's saying we can bring it over and make it positive, bring this over and make it minus 9, right? So y is going to equal 3x minus 9. So it's easier to solve for y here because really it's 2 steps in both, but you don't want any. Right? It's all for x, you're going to get a fraction. Okay? Try to avoid the fraction. What's it easier to solve for here? X or y? X. Small number, right? Y is by itself, so y. What was this here? Solve for y or solve for x? Solve for y. Give me fractions. Because if we're solving for y, eventually we're going to have to divide by 6 or negative 6, right? So we'd have to divide 3 by 6, which would give us a fraction, 1/2, or 0.5, right? But if we solve for x, does 3 go into 6 and into 18? Yeah, so it's easier to solve. We wouldn't have fractions, right? X is the smaller number, so always the smaller value, it's almost always easier to solve for, right? Smaller value. And what about f? X or y? Y is almost by itself, right? And what about g? Fraction, you get 5 over 3 to solve for x. Right? But if you solve for x, you get 3 over 5 there. Solve for y, you get 5 over 3. Okay? You're going to get a fraction either way. And both these numbers go into 15, so that helps a little bit, but so in this case, is it easier to solve for x or y? So if we solve for y, we'll have to bring this over and bring this over here, right? I'll bring this over and divide everything by -3. If we solve for x, we'll bring this over, at least divided by positive. So really, it doesn't really matter, right, in this one. So normally we choose the smaller number of the smaller coefficient, right? Smaller coefficient here is 2. 2 goes to 8 and it's 12, so 2 is going to be this one, right? So x is easy to solve for x. the substitution method, it's called, guys, okay? When solving the system linear equations by substitution, we're gonna always, doesn't matter if we use substitution, we're gonna learn elimination later on. Elimination's a little bit easier, I think. But whatever you're doing, substitution, elimination, you always label the equations. You're always given two equations, so label them 1 and 2, okay? Use one of the equations and one of its variables and solve, okay? Sometimes it's already solved for you, it helps. So we're gonna solve for either x or y in one of the equations. It doesn't matter which one. Then we're gonna substitute that value, that expression, into the other equation, okay? And then we'll solve it, and then substitute the number that we solved for the first one. We'll get a number for x or y, substitute that into one of the original equations. It doesn't matter which one, to solve for the other variable, okay? And then we'll verify the ordered pair that satisfies both those equations, okay? So let's see how this works. We'll do a couple here. Still got some time here, okay? So if you're asked to solve this for x and y, so we have y equals 2x minus 7, and we have 3x plus y equals negative 17, okay? So this is called the system of equations because we have more than one, okay? So first thing we're going to do is label those equations. This is the first one. That was written first, so we'll say that's equation 1. So put a 1 with a circle, and then a 2 with a circle. Jeff, you did writing this down? Okay. Put a 1 with a circle on it. We're on page 13, guys. There you go. Page 13. This is equation 1. This is equation 2. Okay? Do we have to solve for x or y in either equation? Or do we have x or y solved for in one of the equations? Y is solved for in equation 1. So that's going to help us out, right? If this were 2x minus y equals 7, then we have to rearrange that, right, to solve for y. We don't have to rearrange that. Y is solved for. Even though y is equal to the value of 2 times whatever x is minus 7. They're going to cross at some point, okay? So if that's the case, we can say if this y is equal to 2x minus 7, there's a y here, right? So instead of this y, let's make this y equal to this. Okay? What happens if we do that? Y right here. So instead of writing this y, we're going to write 2x minus 7. That's called substitution, right? We're going to take this value of y, and we're going to substitute. Sub equation 1, that means equation 1. 1 with a circle, right? Sub that into equation 2. Okay? So this value of y is going to replace this y right here. So in equation 2, what do we have? We have 3x plus y, right? But wait, what is y? Y is 2x minus 7. So instead of writing y here, I'm going to write 2x minus 7, right? Does that make sense, guys? Right? We're taking this and putting it into there. Y equals that, and this y has to be 2x minus 7. Okay? But what else do we have here? We have 3x plus y. This is y, remember, right? 3x plus y equals negative 17. Okay? Wait, this, I know this is. sure what's happening, you have to let me know. Okay? So what's happening here? Taking this y, throwing it away. What's it doing? This value of y here, which is 2x minus 7. These mean the same thing, right? Still mean the same thing? What is y? Y is 2x minus 7. Here's a y, so it's 2x minus 7. Leave everything else the same. 3x is here, 7 is here. Replacing this y with 2x minus 7. When we do that, look what happens. We have 3x plus 2x minus 7 equals 7. Now we have one equation with just one unknown. We only have x now to worry about. How many x's do we have when we put these together? 5x, right? We can put those because they're like terms. Let's say 5x minus 7 equals negative 17. How do we solve for x? How do x myself? 4 divided by 5. Minus 7 here, right? We have to remember we're going to get rid of this minus 7 by adding 7 to both sides or bringing it over. It's going to be negative 17 plus 7, right? Add 7 to both sides here. What's negative 17 plus 7? Negative 10. So we have 5x equals negative 10. Awesome. Now we can divide by 5, which tells us that 1x is equal to negative 2. Amazing, okay? So now we have a value for x. You know x has to be negative 2. Because this is a system equation, you know x is going to be negative 2 in both equations, right? Okay. Why do we know it's both? Because we put the value of y here. So now we can solve the y. We know x. Now we can go back to either the first one or the second one. It doesn't matter. Which one is up? We can solve for y when x is negative 2. You either put negative 2 in for here for x or here. Right? Which one was easier? Equation 1 or equation 2? Right? You're going to get the same answer for either, right? Equation 1 has a bit smaller numbers, right? So we're going to say sub x equals negative 2 into equation 1. What does that look like when we put negative 2 in for x? Well, equation 1 is y equals 2 times x. But remember, x equals negative 2. We're going to sub that in to here. Right? So y is going to equal 2 times negative 2 minus 7. 2 times negative 2 is negative 4. Negative 4 minus 7 is negative 11. So when x is negative 2, y is going to be negative 11. Therefore, you can say 11 is the point of intersection. There's not a problem. Okay. Here we have 3, which is negative 6. Did you see this in the other comments? No. Maybe not. You guys have any questions for that? Jeff, is that okay? Yeah. Okay. Let's look at the other one. What's the first thing we're going to do here? But y equals 3 minus 3y equals negative 25. Label. This is equation 1. This is equation 2. Okay? First is label. Then we see, do we have to rearrange anything? Or is either of those equations solved for x plus y? Already. Equation 1 solve for y, right? You already know that y is equal to this. Y is the value of 3x plus 5. But wait a sec, here's a y right here, right? So what are we going to do? We're going to replace the y in the other equation with 3x plus 5. Okay? Whenever you replace it, remember this is 3y, or negative 3y, which means negative 3 times y, right? So all we're going to do is take that y out and put in brackets 3x plus 5. That's it. Okay? Before we do that, we'll see what we're doing. We're going to sub equation 1 into equation 2. Okay? When we sub this in for this, what do we get? We get 4x minus 3 bracket. What is y? 3x plus 5. So write 3x plus 5 here. What's that going to equal? 4x plus minus 3y equals negative 25. Okay? This is a y, remember. That's all we're doing. This is still 4x minus 3y equals negative 25, right? One equation now with one unknown. We can solve for x. Just expand this out. So what are we going to get here? We're going to get 4x. What happens if we expand this out? Minus 9x. Awesome. And you have negative 3 times positive 5. Minus 15 equals negative 25. Right. Put our x's together. 4 minus 9. That's going to be negative 5, right? So we have negative 5x minus 15 equals negative 25. How do you get rid of this negative 15? Add 15 to both sides. That's gone. Negative 5x. You don't have to write this. It's negative 25 plus 15. Positive 10. Right, negative 10. 25 negative 50 plus, right? Negative 10. And our last step, guys, by negative 5, right? Awesome. Two negatives make a positive, so this is going to be positive 2. X equals positive 2. Okay, after all that, we have a value for x. What are we going to do with this value of x? Solve it into either equation 1 or 2. 1 looks like smaller numbers, right? So sub that x equals 2 into equation 1. Okay, equation 1 is y equals 3x plus 5, right? But x equals 2, so it's y equals 3 times 2 plus 5. 3 times 2 is 6. 6 plus 5 is 11. Okay? So therefore, what's the point of intersection of this one? 211 is the point of intersection, right? Here was negative 2, negative 11. Over here, it's positive 2, positive 1. Okay? Two different equations. Now, this one's a check question 4B. So we want to check to make sure this is right. We kind of already have checked it. So how do we do a check, guys? Remember, we have to do left side, right side for both equations, right? So we know the point of intersection was 211. Prove our x value, 11, our y value, okay? So this has to work for both equations. So if we look at equation 1, we got the left side, and the right side. What's on the left side of equation 1 here? Y, or just y, right? The right side is 3x plus y. What we want, y is 11. So we substitute 11 in the equation. On the right side, times x, y. 5, 11. That checks it out. That has to look for equation 2 as well. So on the side of equation 2, 4x minus y. Right, 4x minus 3y over here. And the right side is negative 25. When we substitute 2 in for x, it's 4 times 2 minus 3 times 11. Okay. 4 times 2 is 8, so we have 8 here. Minus 3 times 11 is 33. And 8 minus 33 is negative 25. So that checks out for both sides. And then what's another way to check to see if 211 was the point of that intersection? How else can you check that? Easiest way to check. Then you do this stuff. What we were looking at earlier. What's that software called? Decimal. So if there's 2 things in the decimals, it'll tell you that they'll cross at the next 2 y is 11. Why didn't we just do that? But we need to know it, okay? So we're going to do 2 more examples tomorrow. Won't go any past that today. Okay? Tomorrow we'll look at a couple more examples you guys can practice. And then we'll look at the elimination. Oh no, the 2 slides substitute. Yeah, we gotta look at it. Stop.
password is logged out. You're welcome.
Hi. Top three rows. Top three rows on the right. walking around and kind of just get a view of what you guys are doing. Yeah, it's kind of like judging, but it's instructive and kind of teaching. I don't never finish it. I just sit there.
Back to the other side. So my friend and I, okay.
Yeah, sure.
She know how to rap, but she don't know how to snack.
Right.
No, it's a class. It's okay. It's great. Yeah. I might have to take the next week because they do have a area. And then the men's choir, like our guys' choir, they perform at 10. So like, I see the guys are awesome. Okay. So, and then, so if you need to move your phones down, that's fine. I'll talk to you guys about how difficult it is to put stuff away and watch. But you're amazing and thank you for being so patient with me, guys. Did everybody get to reset their passwords and stuff today? Do you guys know how to do that?